Good afternoon, class. We are looking at the final exam review. Here's the last part, part 3, covering page 42 to 61, the last part of the final exam. So, given the integral of f of x dx equals 6 from 1 to 3, from 3 to 7 is 9, from 1 to 3 is minus 4, in this case for g of x. The integral of g of x dx is minus 4. We want to evaluate the following, starting with 3 times f of x dx, the integral from 1 to 3. So basically, you do this, and as you know, this is 6, so the product, or 18. The integral of 1 to 3, 2 times f of x minus 4 times g of x dx. So we are going to use properties of integration. We know this part to be 6, this part to be negative 4, so 2 times 6, 12 plus 16. The integral of 1 to 7, so we can write the integral of 1 to 3 plus the integral of 3 to 7. We simply add them up. The answer is 15. The integral of 3 to 1 f of x dx is the opposite of this value, so the opposite of this number, making it negative 6. Now, we want to take the integral of this function f of x from negative to positive 2. It is defined as a piecewise defined function. F of x is 2 between negative 2 and 0, and z 4 minus x squared from 0 to 2. So we do exactly the same. We cut it from negative 2 to 0, and then from 0 to 2. If it were defined from negative infinity to 0 and then 0 to infinity, we would do exactly the same thing here, okay? This is 2x from negative 2 to 0. This is 4x minus 1/3 cubed from 0 to 2. You simply plug in. You plug in 0 and then negative 2. You plug in 2 and then 0. This is positive 4. 8 minus 8/3. And of course, the second piece is all 0. So 4 and 8, they add up to 12. 12 minus 8, there's 12 times 3, 36 minus 8 is 28 over 3. Just take a common denominator. Remember the FTC. One of them says that the derivative of the integral is the function itself. And the other one says the derivative of the integral as it goes from a to g of x, then it's f of g of x times g prime of x. This one is really f of x times the derivative of x, which is 1. So it's simply f of x. Now it's f of g of x. In this case, your function f of t is the tangent. And so you replace the t with this function, and then by the chain rule times the derivative of the x squared plus x, which is 2x plus 1. And we put the 2x plus 1 in front. What happens when the lower limit and the upper limit are both functions? Again, just to understand this concept. When the lower limit is any number and the upper limit is just the independent variable, in this case x, you put it in. If the lower limit is a constant, any constant, and the upper limit is some function of x, then into this goes that function and then g prime of x by the chain. Now, if it happened to be both functions, okay, the function is f of t equals t squared, and the methodology is to plug in the upper limit and then times its derivative by the chain rule, minus plug in the lower limit and then times its derivative. Therefore, first and foremost, we replace the t with sine x. So we get sine squared of x. Then by the chain rule times the derivative of the sine x, which makes it cosine x. And then minus, let's plug in tan x. And then the derivative of tan x is secant squared x. You really don't have to do much. You can leave it like that, or cosine x sine squared minus tan squared secant squared. That's it. I can rewrite it as cosine x sine squared minus tan squared secant squared. If you want to take this derivative, basically you have to interchange these two to use that, and when you interchange these two, it becomes the opposite of what you see. Okay, that's your function, and it's the opposite when you bring the function up. The lower limit is any number, makes no difference. So replace the t into this function with sine x by the chain rule times its derivative, which is cosine x, and we put the cosine x in front. See, we kept the negative sign. It's important to know the negative sign, of course, doesn't go away. A particle moves along a line so that its velocity is given as such. Find the displacement from 1 to 4, and reminding everybody that displacement is the integral of a to b v of t dt, whereas distance is the absolute value, everything that is covered. Again, basically displacement means from point A to point B. Distance means if you covered, I don't know, zigzag, you have to consider everything. That's really the bottom line. So the displacement is just a simple integration. Distance is the absolute value. So displacement can even be 0 or negative. For example, the area of the top, if it's larger than the bottom, becomes positive, otherwise it becomes negative. You take the integral of that. It's a very simple case. You get 1/3 t cubed minus 1/2 t squared minus 6t. And I'm going to assume everybody can plug in 4 and 1. I just give you the final answer. Just plug in number 4, plug in number 4, number 1. It's a simple evaluation. And so what it means that the particle moved this much to the left. The negative sign means to the left if the right side is taken to be the positive side. And so what about the distance? You have to use the sign graph by factoring this piece into t plus 2, t minus 3. Okay. That's the absolute value, as I mentioned. When you have an absolute value, a piece is positive, a piece is negative, so you have to figure this out. So here's the number line. We can go from negative infinity to infinity, or simply we are interested really from 0 on because is of the timing. However, even if you just do the entire thing and then use it appropriately, it will do fine because we are going from 1 to 4. Okay, so let's do the entire thing. First of all, between -2 and 3, the easiest TP, I'm going to call TP short for the test point, is 0 here. So if you plug it into this function or its factored form makes no difference, it becomes negative. So this is negative, everybody. And then the other two alternate. Now, the reason they alternate, I want to make sure everybody understands. When you factor, if each has exponent odd, not just one, even if it's odd, it will do that. If it's even, it doesn't. So from negative to 3 is negative. So that means from 1 to 3 is negative, right? So we're going to separate it. And then from 3 to infinity is positive. So from 3 to 4. That's how we are going to use that. Because it's negative, in this vicinity, we have to negate the velocity to make it positive. That's the concept. And so with that being the case, let's plug in the velocity function here. It's opposite, minus t squared plus t plus 6 into the first one. Now this gives you negative 1/3 t cubed plus 1/2 t squared plus 60, and this we've already told you. This goes from 1 to 3, this goes from 3 to 4, and again, you can do the evaluation on your own. We get precisely 61 halves, or about 10.17 meters. What does it mean? The distance covered was 10.17 meters, but the displacement was negative. Okay, so from this point, okay, to the left in essence. However, as far as the distance, up, down, and so, okay. I want to differentiate and integrate this because sometimes students make a mistake with this. When you differentiate the exponential, you multiply by negative 0.2. And when you the derivative of sine is positive cosine, so negative sine remains and sine gives you positive cosine, so minus cosine, and you multiply these two and you rewrite. However, to integrate, we put a dx, and when we integrate, we divide by negative 0.2. And the derivative of sine is cosine, but the integral is negative cosine. With this negative makes it positive cosine and a constant. This ratio is 40 divided by negative 2 or negative 20. And let's find the initial value problem with f of 0 being 20, and namely the pair is 0, 20. So we are going to replace the x with 0 and f of x with 20. So as you know, e to the power of 0 is 1, cosine 0 is 1, so you have minus 20 plus 1 plus c equals 20, and therefore c becomes 39. And so now you plug in, and again, reminding everybody that this is a general solution, which means it has infinitely many solutions. And this now is a particular solution. So again, this constant means a family of functions. Now we use the pair to find one specific function. we want to evaluate the integral, reminding everybody of an even function going from minus a to a is the same as going from 0 to a times 2. At an odd function from minus a to a, the integral becomes 0. That's the theorem. And as you can see, they are identical. So times 2, they are identical, but they cancel each other because one is positive, one is negative. So in this case, you can work it out, of course, but it is easier to notice that this is an even function. Here's your f of x. Now, f of minus x is minus x to the power of 6 plus 1, which is the function itself. So we have to show it, and we did. And therefore, instead of negative 2 to 2, we're going to go to 0 to, but we multiplied by 2. And the difference is easier to evaluate it. Of course, we can write this as 1 over 7x to the power of 7, and this one plus x. But if we were to evaluate it from negative 2 to 2, it would take a little bit longer. So replace the 2 here, replace 0 doesn't give you anything. That's why it doesn't take long. Just plug in 2, and this is 248 over 7 plus 4, and that's what you get. However, this function, we don't have a way of doing it yet. And so we can see that the answer becomes 0. And why is that? We can prove this is an odd function by recognizing the function x is tan x. It's everything here except the x. So tan x over 1 plus x squared plus x to the power of 4. So what is f of negative x? This becomes tan of negative x. So I want to make sure we understand that really f of minus x is tan of minus x over 1 plus minus x squared plus minus x to the power of 4. And this is equal to minus f of x, which proves it's an odd function, and it proves the answer is 0. First, we change square root of x to x to the power of 1/2, and then we make up two fractions. And we notice this is x to the power of 1. So according to the exponential rules, we end up with those. So far, nothing but elementary algebra. This is 1 over 1/2 plus 1 x to the power of 1/2 plus 1. This is 1 over negative 1/2 plus 1 x to the power of negative 1/2 plus 1. And of course, a constant. Needless to say, 1/2 and 1. 3/2. Negative 1/2 and 1 is 1/2. So when you divide by 3/2, it's the same as multiplication by 2/3. When you divide by 1/2, it's the same as multiplication by 2. Substitution method in the case of polynomials. Okay, the more complicated one is a choice of u. Remember, look for a function u equals g of x anywhere in the integrand and its derivative du or g prime of x multiplied by dx. So if u is x to x squared plus 5, du dx is 2x, and therefore du is 2x dx. So we're going to move the 2x next to dx. So we can clearly see we are dealing with u to the power of 30 du, which makes it a simple case of a power rule. So 1 over 31 u to the power of 31 plus a constant. and you replace the u accordingly, and you end up with the proper answer as 1 over 31 times x squared plus 5 to the power of 31 plus a constant. What happens when we are dealing with a fractional format? First and foremost, so we have to simplify, put it in lowest term if we can. Otherwise, the denominator is a choice of u. As you can see, this expression is e to the power of t, and therefore du is e to the power of t. dt, I can put that next to e to the power of t, and therefore the integral of du over u, which is simply a natural log, and you plug in, you're done. You always have to try to simplify. This can't be simplified. Denominator is a choice of u. Its derivative is 2x plus 2. Therefore, 2 times x plus 1. So du is 2 times x plus 1 dx. We are going to rewrite the expression by putting the dx in the numerator. And as I've mentioned it before, anytime a number is missing, all you have to do, throw in the number and undo it with its reciprocal. Again, this is the fastest way, class. This is not the only way. Some people don't even do it this way. They solve for dx, but this is the fastest way. Only when we are dealing with numbers, we can do that. And so we are looking at, again, the natural log. This time u is different, of course, and the answer is half of natural log of the absolute value of x squared plus 2x minus 1 plus a constant. And again, reminding you, you could get rid of the absolute value, put a parenthesis here, but not here because this expression is positive. You could do that. If we look at the reciprocal of one of them, for example, this one, you don't have to use the substitution. You just write this 5 over e to the power of t, this one, and then this one. And this is minus 5 e to the power of negative t. This is plus t and a constant, and you're done. By the way, if this happened to be the case, you have to do long division, okay? So there will be two portions in that case. What happens when natural log is concerned? That is almost always the case, that you choose u to be ln x. Its derivative is 1 over x. Therefore, du is 1 over x dx, or du or dx over x. And we are going to rewrite the expression. I highly recommend you always do that. It becomes clear for you, because even if it's clear now, maybe sometime down the road you check it, it makes no sense to you. So you rewrite it for that purpose, and it becomes clear that you're dealing with the integral of u squared du, which is a simple case of a power rule. So 1/3 u cubed plus a constant, and you replace the u, and you're done. Again, you're dealing with a fractional expression. You notice the derivative of the bottom is the top. Therefore, if you choose the bottom to be the u, the top times dx is du. And it's the integral of du over u, which is a natural log. And now you're going to replace the u, and you're done. We want to integrate. The independent variable is theta. This is 5 theta. Cosine, the derivative is negative sign, but the integral is positive, and we are done. Exponential. Anytime exponential is involved, most likely the choice of u is the exponent, in this case, x to the power of 5 minus 2. You know its derivative is 5x to the power of 4. Therefore, du is 5x to the power of 4 dx. And we're going to move the x to the power of 4. And again, notice a number is missing. You just throw in the number and it's reciprocal. Now, again, whether you put this in or outside the integral sign makes no difference. The reason I put it outside, it makes it easy to just keep it, okay? Because it's not going to go away. However, this becomes e to the power of u du. And the answer is simply 1/5 e to the power of u and a constant, and the u is replaced, and we are done. It's pretty straightforward. Again, we are dealing with a natural log, and that's the choice of u. Its derivative is 1 over x plus 1 times 1, so du is the same thing times du. Again, I like to rewrite this so it becomes clear what I'm dealing with. So this is u, this is du. Separate them in this fashion so it becomes clear. And so when I do that, I'm not going to write the limits yet because I want to make sure we know how to figure it out. Plug in 0 gives you ln 1, which is 0. Plug in 1 gives you ln 2. And basically plug in ln 2 because the bottom is 0. When you plug in, gives you 0. So that's the exact answer. dt over cosine squared t times 1 plus tan t. So when you have a case like that, something has to give. So if you rewrite this such that cosine squared comes up, becomes secant squared, right? Because 1 over cosine squared, 1 over cosine squared is the same as secant squared. You notice if you choose the bottom to be u, the top is du. Because the derivative of tangent is secant squared. So a simple case of integral of du over u resulting in a natural log, and replacing the u gives us the final answer. Sinusoidal functions. The argument has an exponent, that's a choice of u. Its derivative is 2x. Du becomes 2x dx. Again, get to the habit of rewriting it, it becomes clear what you're dealing with. So again, they solve for dx. I don't like to do that. I just throw in the 2 and it's reciprocal. Again, this 1/2, you can even write it here or here, doesn't matter, it's a multiplier. It remains as a multiplier. So you're dealing with half of the integral of sine u du. The integral of sine is negative cosine. So negative 1/2 cosine u on a constant, and replace it and you're done. In the case of part B, when sine and cosine are both involved. The one with the exponent is the choice of you. Sine x has the exponent. Of course, when you choose it without the exponent. Again, everybody knows this is sine x to the second power. The derivative is cosine x, so du is cosine x dx. And it's a simple case of a power rule, 1/3 u cubed and a constant, where u is replaced by sine, and we are done. Just to make sure we really are comfortable with this concept, if you look at this one, this time cosine has the exponent 20, and that's the choice of u, and its derivative is negative sine x. So du is negative sine x dx. We're going to rewrite this. When we do that, we need to put a negative sign here, which means multiplied by -1, and undo it here. The product of these two, they cancel each other. They give us just +1. And so what you are dealing with here is u to the power of 20 du, which gives you this negative sign remains minus 1/21 u to the power of 21, and a constant. You replace the u with cosine, and you're done. And again, we are keeping the negative sign, okay, everybody? Now, again, as usual, all you have to do, integrate the result. It gives you the same thing without the dx. Okay. Could somebody read this question, please? Anybody feels like reading for us?
Many fish grow in a way that is described by the von Bertalanffy growth equation. For a fish that starts life with a length of 1 centimeter, it has a maximum length of 30 centimeters. This equation predicts the growth rate is 29 e to the negative x squared centimeters per year, where x is the age of the fish. How long will the fish be after 4 years? Round your answer to one decimal place.
Excellent. All right, so if we let L of x represent the length of the fish at any age, then this is its derivative. So L prime or dl dx is that one with the initial value being 1 centimeter. There are two ways to do that. I'm going to approach both ways. First, this represents what's called the accumulated change, and we can see the amount of increase over the course of 4 years by integration from 0 to 4, the amount of increase in length. And so 29 divided by -1 makes it minus 29 e to the power minus x. You plug in 4 and 0. And again, this itself is an approximation. It's not precise, so you go with some decimals. L of 0 was 1, and you must add these two numbers. And then this is the answer. Now, 1 decimal, so 4 Next to it is number 6, it goes up to 5. So that's one way to do it. The other way is to just find the length in general, which means you just integrate this and you find first the indefinite integral, which means you have this one plus a constant, and then it becomes an initial value problem with that by replacing the x with 0, and this must become 1. So that gives us a chance to find the missing k. So we have minus 29, right? Because e to the power minus 0 is 1, plus c equals 1. So c is 30. And now a general solution becomes a particular solution. Since we want the length at, this is the length at any age x, and now 4 years later, 10 years later, 20 years later, just plug in 4, and it will give you the same answer. So both methods work, your choice. Find the absolute max and mean for this function in this closed interval. First and foremost, when we use what's called a closed interval theorem or the extreme value theorem, we have to justify the continuity. This function is a polynomial of degree 4. It has a domain, or you can say it's continuous from negative to positive infinity. Therefore, it's continuous in the given interval. That's the first thing. So we need to differentiate this in order to find the critical points, and we get 4x cubed minus 36x. Since we want to set this equal to 0, we are going to factor out the 4x first, and then this one into x plus 3x minus 3. Now, if I set this equal to 0, this becomes 0, this becomes negative 3, this becomes positive 3, resulting in 3 numbers, 3 answers. Are they all in this interval? No, only 0 and negative 3. Also, we are still in number 1, so f prime equals 0 gives us the answer. F prime does not exist, doesn't give us any answer, okay, because f prime itself is a polynomial. So we are going to evaluate the function at the endpoints as well as 0 and negative 3. All you have to do just plug in. 0 is the absolute max, minus 81 is the absolute mean. Here's the way I write it. In this pair, but you have to be very careful to see how they want you to answer. You answer it accordingly in order to receive full credit. We're going to evaluate this integral, and we're going to go through the substitution. Let u be 25 minus x squared. Its derivative is minus 2x. Therefore, du is minus 2x dx. And we're going to rewrite it. Again, you can solve for dx and go through the process that the text does, or simply throw in minus 2. Its reciprocal is negative 1/2, and rewrite it in the following manner. I'm not going to write the limits yet. I'm going to discuss that in a moment. This is u to the power 1/2. We have seen this many, many times before. 1 over 1/2 plus 1, u to the power 1/2 plus 1. We keep this one. And 1/2 plus 1 is 3/2. 1 over that is 2/3. Let's write that. 3/2, 2/3. Their product is negative 1/3. And you can go back to the original variables, original variable x and original limits 3 and 4. Or you can say if I plug in 3 here, I get 9. 25 minus that is 16. If I plug in 4, I get 16. 25 minus 16 is 9. And those are the new limits. So I'm going to plug in the new limits to do the evaluation. Again, a lot of algebra class. Okay, so just for the sake of argument, this is the only, the asterisk, calculus step. Everything else is algebra. So you plug in to evaluate, you know, this is 3 cube it, you get 27. This is 4, you cube it, you get 64. Their difference is negative 37. And their product is positive. A farmer with 240 feet of fencing wants to build an E-shaped enclosure beside a creek, as seen in the diagram. Find the maximum area. So let's throw in some variables. The objective is to maximize the area of x equals a equals xy, subject to 240 feet of fencing. 1, 2, 3x plus 1y is 240. And that's really the core of the material, understanding the question, and now the rest is elementary. You solve for y, you plug it in here, and it becomes a function of x. This is an open interval. The reason is x is positive because it represents dimension. The reason is less than 80 because if you set this equal to 0, x becomes 80. If you choose x to be larger than 80, this becomes negative. And therefore the area becomes negative. So you have this open interval of 0 to 80. So you distribute. So you can differentiate 240 minus 6x. So you can set it equal to 0 to find the critical points, and it becomes 40. So you have one critical point and an open interval. So local becomes absolute, the best course of action. Whether this is a local max or mean, which becomes an absolute max or mean, we don't know yet. So we do the second derivative test, and this becomes -6. And we are interested in the negative because negative means concave down. Maximum occurs when x is 40. Put it into this or into that to find the missing y. Those are the dimensions, everybody. 40 by 120. The area is their product, 4,800 square feet. A box with a square base and open top must have a volume of 32,000 cubic centimeters. Find the dimension that minimizes the amount of material used. Reminding everyone of the following formulas. A rectangular solid, the volume is the width times the length times the height. Surface area like gift wrapping, and that's exactly what we need here. The width times the length plus height times the length plus height times the width times 2. If all sides are equal, V becomes S cubed, SA becomes 6S squared. So in this case, the gift wrapping, the surface area is x times h. There are 4 walls and they're all identical for xh. The bottom is x squared, normal is x squared, plus x squared meaning 2x squared. But it's open top, we don't need the top, and therefore it's 4xh plus x squared. The constraint is the volume, which is x times h, or x squared h equals 32,000. Now we are in business. We're going to solve for h first. We're going to replace it here. And 4 times 32,000 is 128,000, and x cancels out the x squared. Now it's a function of one variable. We rewrite this as bringing the x up for the sake of the next step, which is differentiating, and x must be positive because x represents dimension. So you have an open interval of 0 to infinity. To differentiate, multiply these two, you get negative 128,000 x to the power minus 2 plus 2x. You put this down here and you take a common denominator for the next step. So I put the x squared down, I get rid of this. Because I want this to be equal to 0 and where it doesn't exist. So if you set it equal to 0, results in 2x cubed being 128k, and x cubed is 64k, which gives you x equals 40 centimeters. If you set the denominator equal to 0, you get x equals 0 is not in the domain. So there is this open interval, there's this one critical point, therefore local becomes absolute. Is it local or absolute? Max, mean, we don't know yet. So to prove that, again, we go with this second derivative test. So here's S prime here. The product of these two is positive 256,000 x to the power minus 3 plus 2. You have to plug this in. I hope you realize if you plug in, you get 256,000 over 40 cubed, which is positive, plus 2 is even more positive. And it makes it concave up. Concave up means minimum. So minimum occurs when x is 40. You use either this formula or this formula. If you plug in 40 squared, and then you find the h to be 20, those are the dimensions. They haven't asked for this, they haven't asked for the material. You can plug in, however, those values, and this is the minimum amount of material we need. We want to find the area of a region that is bounded by these two graphs. One of them is a line, f of x is 2x plus 1. One of them is a quadratic function, a parabola, g of x is x squared plus 1. And I remind you that I like to use an increment of the area. This is called an increment of the area, that concept. And I always use a rectangle, h times dh. H is the height, or length, if you will. Dh is the width. So first, we're going to graph this. I'm going to assume nobody has any problem with graphing the two functions. So this is a line, and this is just x squared up by 1 unit. So it's a very simple case. You need to find the points of intersection, and not necessarily from the graph. You really have to work it out. So if you set them equal, and if we get rid of the 1 and we bring it to the same side, as you can see, it becomes x times x minus 2, and x is either 0 or 2. So 0, if you plug in, gives you 0, 1. 2, if you plug in, gives you 2, 5. So those are the pairs. And you need both coordinates, because we don't know yet if we are going to go with delta x, in other words, dx or dy. When you find out, then you see that which points you. So we're going to evaluate the integral. And so I'm going to draw an increment of the area. Clearly, one of them is at top of the other one. Okay. You could also say one is at the right side. That all it in this case it happened to work. Okay. And so what is this height? Y of the top, y from the line minus y of the bottom from the curve. So 2x plus 1 minus x squared plus 1. And this increment, we're going to move this along the x-axis. So this dx, this is dx, okay? So this is the height, f minus g, and this is the width, dx. And so integrate this, because you're dealing with the x, you need the limits on the x coordinates, 0 to 2. Now it's a simple case of integration. So first of all, you rewrite this, because 1 and negative 1 cancel each other. So this is x squared. This is minus x cubed over 3. Plug in 2, 0 gives you, and plug in 0, 0 gives you 0. So plug in 2. This is 4, this is 8. So 4 minus 8/3. So 4 times 3, 12 minus 8 is 4/3. And that's the final answer, everybody.